Welcome back to Database Internals Crashcasts. I'm Sheila, and I'm here with Victor. Before we dive in, we'd love to hear from you. If you're enjoying our podcast, please take a moment to rate us on your favorite podcast platform. It really helps us reach more database enthusiasts like you.
Absolutely, Sheila. Your support means the world to us. Now, let's get started with today's exciting topic, the relational model. This is the first episode of our new season on relational database systems, and we're kicking things off with the fundamental concepts of the relational model.
That's right, Victor. And to get our listeners thinking, I have a quiz question for them. Who is credited with creating the relational model for database management? Don't worry if you don't know the answer right away. We'll reveal it at the end of the episode.
Ooh, that's a great question, Sheila. It really gets to the heart of the history behind this crucial concept in database management. I'm sure our listeners will be intrigued to learn about the brilliant mind behind this model that has shaped the database world for decades.
Absolutely. Now, before we dive deeper, let's start with the basics. Victor, could you explain what exactly the relational model is?
Certainly, Sheila. The relational model is a way of organizing and representing data in a database. It's based on the concept of relations, which are essentially tables containing rows and columns of data. This model was a game-changer when it was introduced because it provided a simple yet powerful way to structure and query data.
I see. So, if I understand correctly, when we talk about relations in the relational model, we're basically talking about tables, right?
That's a great way to think about it, Sheila. Yes, in database terminology, a relation is equivalent to a table. It might help our listeners to imagine a spreadsheet. Each sheet in the spreadsheet would be a relation or table in our database.
That's a helpful analogy, Victor. Now, I've also heard the terms tuples and attributes used in relation to the relational model. How do these fit in?
Excellent question. In our spreadsheet analogy, tuples would be the rows of the sheet, while attributes would be the columns. In database terms, a tuple is a single record in the relation, and attributes are the different fields or properties that make up that record.
That makes sense. So, if we had a relation called employees, each tuple would represent one employee, and the attributes might be things like name, ID, and department, right?
Exactly right, Sheila. You've got a good grasp of the concept. Now, one of the key strengths of the relational model is its structure. Each relation has a defined schema, which means that all tuples in a relation have the same set of attributes. This structured approach makes it easier to organize, query, and maintain data.
I can see how that would be beneficial. But Victor, I'm curious. How does the relational model compare to other database models we've discussed in our previous season?
That's a great point to bring up, Sheila. The relational model offers several advantages over earlier models, like the hierarchical or network models. It provides better data independence, meaning changes to the physical storage of data don't affect how we interact with it logically. It also allows for more flexible querying through languages like SQL, which we'll discuss in future episodes.
Fascinating. It sounds like the relational model really revolutionized database management. Are there any potential drawbacks or challenges with using this model?
Indeed, there are some considerations. While the relational model is excellent for structured data, it can sometimes struggle with very complex data structures or when dealing with extremely large datasets. Also, ensuring data integrity and consistency across multiple related tables can be challenging, especially in distributed systems. However, these challenges have led to the development of various techniques and technologies to address them.
That's really interesting, Victor. It seems like understanding the relational model is crucial for anyone working with databases. Do you have any tips for our listeners on how to remember these key concepts?
Absolutely, Sheila. Here's a simple mnemonic. RAT, relation, table, attributes, columns, tuples, rows. Just remember, in a database, you're dealing with rats. It's a bit silly, but it might help our listeners remember the three main components of the relational model.
That's a great memory aid, Victor. I'm sure our listeners will find it helpful. Now, before we wrap up, let's reveal the answer to our quiz question. Who is credited with creating the relational model for database management?
The answer is Edgar F. Codd, a British computer scientist working for IBM. Codd introduced the relational model in his seminal 1970 paper, A Relational Model of Data for Large Shared Data Banks. This paper laid the foundation for relational databases as we know them today.
Thank you, Victor. To summarize today's episode, we've learned that the relational model organizes data into relations, tables, composed of tuples, rows, and attributes, columns. This model provides a structured, flexible approach to data management, revolutionizing the field of databases since its introduction by E.F. Codd in 1970.
Excellent summary, Sheila. In our next episode, we'll dive deeper into the specifics of relations, tuples, and attributes, exploring how they work together to create powerful database systems.
I can't wait, Victor. And to our listeners, thank you for joining us today. If you enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you. Until next time, happy data modeling.